Okay, so now we're going to look at a special case. These are our perfect cubes. This is the sum of two cubes. So I have a number cubed plus another number cubed, and then the difference of two cubes. Now the cool part about the sum and difference of two cubes is that you literally plug it in. So all you have to do is figure out what the A and the B are. So in order to do that, we have to know what our cubes are. So we can write down a table of all of our perfect cubes, or we can plug in x cubed into our calculator and see what each number cubed is. Now again, you're looking in the y column, okay? So x cubed in number 1, that's easy enough. It's obviously x cubed. 27 is a little trickier. So let's go down. 27 is 3 cubed. That's what lines up with 27. So I'm going to write this as 3 cubed. So now the x becomes the A and the 3 becomes the B. We're going to just plug it in. Now notice I have a positive sign here. Now the cool part is your binomial, which comes first, always uses the same sign. So it's just going to be x plus 3. Then the binomial uses the opposite sign and always positive. So we say we have a nice clean perfect cube because we use soap. Same, opposite, always positive. So I have my same sign. Now I have a squared. Well, a is x, b is 3, so a squared would be x squared. Opposite sign, opposite of positive is negative. Now I do a times b, so that's x times 3, 3x, always positive, plus sign, b squared. b is 3, so that gives me a 9. Now the interesting part about this is that the trinomial cannot be factored. We would actually have to use quadratic formula on that, which we will do in the next unit. So once you've plugged in the a and the b, you're finished with the problem. It's one of the shortest factoring problems out there that actually looks hard at the beginning. So let's look at number 8. It's a perfect cube. I have an x cubed. But I'm looking at this and I'm thinking 5 is not an x cubed, a perfect cube. So I need to get rid of that 5. Well, I'm in luck. 40 is divisible by 5. So let's do a GCF. Pull out the 5. What's going to be left? 40 divided by 5 is 8. Got rid of the 5, just left with x cubed. Well, now let's look at our table. Do I have an 8 in the table? Yes, I do. That goes with 2. So A is 2 and B is x. Okay? Because you can essentially think of this as 5 and you have 2 cubed minus the x cubed. Alright? So now we're going to write out our binomial and our trinomial. I keep the 5 on the outside. We can't lose the 5. Okay, binomial. A, same sign, B. So 2 minus x. Remember to keep them in that order. Don't switch it around and get your sign in the wrong spot. Now I need a squared. A was 2, so a squared is 4. Opposite sign, it's going to be a plus. Now it's a times b, so 2x. That's easy enough. Last sign is always positive. Same, opposite, always positive. Always positive what? B squared. Well, b was x, so that gives me x squared. Now yes, this last one has all plus signs, that wonderful trinomial. So you could turn it around. I'd keep the binomial the way it is. But that trinomial is really bugging you because we always like to write our highest power first and write it just like that. And again, the trinomial is not factorable, so you are finished.